In today's functional analysis class, we are going to continue our discussion on validity of closed graph theorem and open mapping theorem. So we have another example. Let x equal to c dash of ab and y equal to c of ab, both with subnorm. Then y is a Banach space and x is a proper dense subspace of y and x is not a Banach space. For x in X, let f from x to y be defined by f of x equal to x prime, the derivative of x. Then f from x to y is linear and f is a closed map. To see that f is closed, let xn converges to x in X and xn prime converges to y in y. Since convergence in the subnorm is uniform convergence, by analysis, x is differentiable on AB and x prime equal to y. That is y equal to f of x. Therefore, f is closed. However, f is not continuous, because if we let xn of t equal to t minus a divided by b minus a the whole raised to n, where t belongs to AB, closed interval AB, then subnorm of xn is supremum modulus of xn of t such that t belongs to AB. So this is supremum modulus of t minus a divided by b minus a the whole raised to n such that t belongs to AB. And you know, subnorm of f of xn, this is equal to a supremum modulus n into t minus a divided by b minus a the whole raised to n minus 1 into 1 by b minus a such that t belongs to AB. And you can see that this is n. So this is n and subnorm of f of xn is n. This tends to infinity as n tends to infinity. Therefore, f is not continuous. So this is an example of a closed linear map which is not continuous, and this shows that closed graph theorem fails if X is not a Banach space. This is an important example of a closed linear map which is not continuous, and many differential operators fall in this category. Now we can show that open mapping theorem fails if Y is not a Banach space. So example, let x is equal to c dash of AB with the norm x equal to supremum norm of x plus supremum norm of x dash and y equal to c dash of AB with subnorm. Then X is a Banach space and Y is not a Banach space. For x in X, let f from x to y be defined by f of x equal to x. Then f from x to y is linear, and f is continuous. F is continuous since subnorm of f of x, this is equal to subnorm of x. This is clearly less than or equal to subnorm of x plus subnorm of x prime. So this is equal to norm x. That is subnorm of f of x less than or equal to norm x. Therefore, f is continuous. Now consider f inverse from y to x be defined by f inverse of x is again x. Then a norm of f inverse of x, this is equal to norm of x, because f inverse of x is x, and this is equal to norm subnorm of x plus subnorm of x prime. So this is clearly greater than or equal to subnorm of x. That is norm of f inverse of x is greater than or equal to subnorm of x. Therefore, f inverse is not continuous. This implies f is not open. Therefore, open mapping theorem fails if Y is not a Banach space. So that's all for today. Have a nice day.